Hello, this is Dr. B. This is a quick introduction lecture to projectile motion. So as you can see in this GIF, whatever it is called, somebody is jumping off of this diving board and landing on the trampoline water thing, and this person gets launched in the air. So I think you've seen something like this before. I don't know if this is real, probably it is. I don't know. The texture is too grainy to see if it's real, etc., or if it's not just some CGI fake thing. So imagine throwing some object in the air. It has to be near the surface of the earth. So if the only significant force acting on it is gravitational force, we call this projectile motion. So just kind of keep this in mind. So there are a lot of forces that act on objects, act on people, whatever. The first one that we're talking about here is called gravitational force, or F sub G. You'll see in the next unit, when we talk about forces, that there are a lot of different types of forces, but this is just an introduction to the first one. So, throwing a tennis ball in the air, flipping a coin, the guy getting launched off the water trampoline thing by somebody else, that's also an example of projectile motion. So for these types of motions, projectile motion, there must be the following things to be true. So, number one, the horizontal and vertical motion of the object are independent. So the motions are independent of each other except for the time. The vertical acceleration is constant at negative 9.8 meters per second squared. That's something you should know already. And horizontal velocity is constant. So I know that's a lot of stuff being thrown at you, but you should keep these things in mind. And when we do our lab simulation, hopefully, when we do our different activities, assignments I have planned, these things you will hopefully realize as we're doing them. So let's look at this really quick. So then last time. So a couple of things that we noticed, okay? So they start at the same height, and then they also hit the ground at the same time, even though there was some different motion, if you will, between the two different balls. So it doesn't matter that the first one has a horizontal velocity. This motion is independent of the vertical motion. They start at the same vertical position, or the position, initial position, dropping down to the final position, displacement, all those things, and they have the same vertical velocity, 0 meters per second. Therefore, they have the same motion in the vertical direction and hit the ground at the same time. So I'm sure you've done something similar to this. A water hose is an example of projectile motion. As long as the only force acting upon an object is the gravitational force, the motion will be considered projectile. However, if you think about it, if you remember from chemistry, hopefully, that each water molecule, you have the oxygen, and then you have the two hydrogens on the end. So this is slightly negative, this is slightly positive end. If you look at each individual water molecule, so to speak, there's a lot of different forces acting on each other. However, if you think about the fact that there's a lot of water molecules interacting with each other, that all these interactions kind of just add up and they can be sort of canceled out or considered negligible, meaning they can be ignored. In the end, water itself, as you see it in this GIF, that it can act in projectile motion. So what is the official definition of projectile motion? We keep on talking about it. Here's what it is. So the official definition, it's a form of motion experienced by an object or a particle or a projectile that is projected, a lot of projected words in there, near the Earth's surface and moves along a curved path, which we'll talk about in a minute, under the action of gravity only, the F sub G that we talked about briefly. However, there are other factors that kind of come into play, but one of them is considered negligible, meaning that it can be ignored slash it's so minimal it doesn't really affect whatever's going on. So one of these is called air resistance. The reason why it's considered negligible is because incorporating it into what we're doing, it makes it so much more complicated, and that's definitely beyond the scope of high school and even some college physics as well. So, in terms of a little bit of history, so around 1604, 1608, so Galileo Galilei, he actually kind of, not say he discovered this, but he kind of, yeah, I guess he kind of discovered this. So he showed that this curved path was known to be a parabola. You should recognize that term, hopefully, from I think one of your math classes. So what he did was he placed an inclined plane on a table and provided it with a curved piece at the bottom, which then deflected some bronze ball into a horizontal direction. So the ball accelerated and rolled over the tabletop with uniform motion and then fell off the edge of the table. Wherever it hit, it left a small mark, and you can kind of see the diagram on the side over here. The mark allowed these different distances, horizontal and vertical, to be measured. By varying the horizontal velocity, the vertical drop of the ball, he was able to determine that, if you notice, that the path is always in a parabolic, so parabola shape. So you're going to see that in the different activities, simulation, lab, however you want to describe it, you're going to see that later on. So for now, we're done with our brief introduction into projectile motion. So if you have any questions, please let me know and hit that like and subscribe button. Thank you.